Hey, and welcome to this very special lockdown PerfGuild 2020. Hey, I'm Jonathan Wright, and today I'm going to be talking to you about digital experience analytics. Now, we've only got 25 minutes, so it's going to be fast and furious, but you're going to learn loads. So let's start. Quick shout out to Scott Moore, who'll be talking about effective performance engineering. My friend Todd DiCaprio, who hosts the website effectiveperformanceengineering.com and has written the book, which you can download from O'Reilly, which will give you a great source on how some of these patterns can be applied. Now, we're looking at OpenStack here, so everything we're going to talk about will run on a Raspberry Pi or some kind of low compute device. Okay, so you may have heard of Performance Application Lifecycle, known as PAL. This has been around since the early 90s, so you can see here back in 1998 I was performance testing against what we would class as a client server written in Java. You might be familiar with multi-tier, service-oriented architecture, model view controller, or even serviceless architecture, which is going to feature through this presentation. But you're going to be able to run this on an OpenStack. So like I said, it should run on a Raspberry Pi. I'm going to be talking about Torus. And I'm also going to be talking about JMeter, which is on the right hand side. We're going to talk about the tick stack, which includes InfluxDB, which is a time series database, Prometheus, of course, and Grafana. And then we're going to talk about Kali and Portswagger. And also we're going to be using Fiddler. All of this stack is available open source. So what platforms are we going to look at? Well, we're going to look at the Google Merchant Store because it's something which is demo and everyone can have access to. I'm going to be talking a little bit about the COVID Safe Paths application, which I'm doing right now, and also some of the work that I've done for Brexit and some test performance engineering against AI as a platform. So things like Neo4j, computer vision, so TensorFlow, and things like Kafka. Okay, so you can see in the bottom right hand corner, we've got GraphDB. We've got some pure path here looking at the Brexit program and the Safe Paths geofencing for GPX locations. So everyone knows about Google Analytics. And Google Analytics, to me, is what I would call a customer experience analytics platform. Now, what we're trying to do is we're trying to get to a digital experience analytics platform. So this is taking a level above customer experience and above APM, so application performance management tools. But this is a great way to start and look at how we're going to shift right. So we're going to create a digital twin. The example we're going to use is Google Analytics, the Google Analytics and Google Store. So what we're going to do, we're going to be looking at certain types of data: social demographic, browser data, mobile experience, site content, speed, and the search. Okay, so we're having a quick look at the Vivek Worldwide website to give you a view, but let's quickly switch to Google Merchant. I've obviously changed the date, so it's 2016. First tip, site search terms. So this is really important because this gives you the ability to understand what are people searching for on your website. So that's what the search terms you can make into a data-driven approach to look at the pages. Second tip is going to be around demographics. You can pull out data such as what gender split it is, the age groups, age group by gender if you decide you want to use a secondary dimension. All good information you can export straight via the advanced into CSV. So this gives you a really good view of what your user pattern is and what kind of people. But of course, that's only half of the story. We're really interested in is what are the technologies behind that. So let's quickly look. Browser and OS. Straight away, I can see Chrome is the biggest one. I can look at the versions of Chrome, and I also can look at the bounce rates. So if I break this down and look at every version of possible Chrome, I can see if there's any particular versions that I need to keep an eye on. So quickly looking at this version, I'm getting 100% bounce rate on 27. So I need to test that. Secondly, I can look at network. Network's important because also if you're getting high bounce rate, could be a problem with some kind of network. Another item which is really important, of course, is location. So this is where your network virtualization capability comes in. Of course, lots of people in the US, but I'm going to have a quick look in the UK. So the UK, I can even do secondary dimensions such as age. And I also can break that down. So I can break that down into mobile devices. In this case, 70% desktop devices still, and not a lot of mobile devices. But we can break that into mobile devices if we want. So we could look at iPads, everything else. So we can also look at the versions as well. So iOS 13.5 beta 2 at the moment with the GPX information for COVID is out. But you can see how each one of those is performing and the metrics around sales. So that's a real brief intro. You can also see here about which pages are accessed the most. So we're going to use this as our blueprint to work out the profile that we need to actually understand what pages have been accessed and make that shift right. So very quick, very easy. We're also looking at site speed. We're looking at what pages load up and the load times that are there. So you can see there we've got a 7.68, we've got an 8.3 coming from the YouTube page based on a Google Read drive, so we can actually quick look at the page selections. These APIs are available to anyone. By launching this page speed insights, I can quickly look and it make recommendations of what issues potentially are there, so things like images. Another one is Google Lighthouse. This is a plugin which you can throw into your Google Chrome. You just generate a report on any page that you want to, and the report viewer will tell you the performance score, recommendations, accessibility information, and also best practices and SEO recommendations. So everything you could possibly need, very quick, very easy. Rewatch this slower to get exactly how you can do it. I just want to get through the basics of how we capture that information. All right, let's move on to the next component. So what we've done is discovery. We've looked at the endpoints and we've also looked at the data sets, i.e. that search terms component. So this can make my data set with all my end URLs, and what I'm going to do now is I'm going to do some mining, otherwise known as process mining, across the entire website so I can get a picture of what's happening at the moment in production. So I need to be able to hook into this technology, so I'm going to use different tools for different layers. So that's the request response pairs, which you might get in something like Postman. I'm going to be looking at the middleware, so I'm going to be looking at Kafka. I'm also going to be looking at the data layer, so things like GraphDB. But also, I want to look at things like network, so things like Wireshark, to be able to capture my PCAP files to see how my network's performing. So lots of different tools at lots of different layers. In the next demo, I'm going to show you how to reverse engineer. Now, for those who don't know what that is, what you can do is we're shifting right. So you could use end users doing UAT on an environment. You could get Fiddler or another tool listening to all the traffic that's coming through to your app server through port 80. You could also run your automation tests, which you've already got, to capture those and turn those into performance scripts. You could be running a whole stack of API tests from Rest Assured or Postman. You could also be running things at a lower level, WinSocket, WebSocket. You could be loading data in. You could also be artificially injecting noise into there as well. So we're going to cover that later. Okay, I'm going to show you how to create a digital twin of the Google store we've just looked at in Google Analytics. And we're going to use those pages to understand what our transactional mix should look like and give us a base profile for what's happening right now in production. Okay, so we need a proxy which configured to Burp Suite that then passes over to Fiddler. So we refresh the page, it's captured by PortSwagger, forwarded on to Fiddler, and now we have the transactions. If we forward all of those transactions across, as the page loads up, you're going to get that entire image, otherwise known as an Internet Archive file. So what we're going to do is we're going to export that out to perfdriver.io, which you can download today, and then we've got every single request and response pair that's required on that main web page. So now we've got that one. What we're going to use is a spider. Now what the spider is going to do, it's going to traverse the entire website. It's going to look at every single directory structure, and it's going to create a model on the right hand side. So as we can see, it's done 196. We're going to run this because it's going to take about 10-15 minutes. So as you can see, it's 206. Let's fast forward to 224. 15 minutes later, we've captured 3,000 request response pairs. And we've also on the left hand side, you can see we've got half of that number is the amount of requests that have been done. So now we're going to do exactly the same thing. We're going to export that to the perf driver converter, and then we're going to read that in to JMeter. You can see there we've got the entire list in Excel of every single endpoint. On the left hand side we've got the traverse directory structure of the entire web page, and now what I'm going to do is I'm going to import that perfdriver.io output. So I'm just going to literally go merge, add the file that we've done, which is going to bring in every single one of those request response pairs that we wanted before. And as it does that, we'll then be able to rerun that exact scenario. Now you could do that directly from using your Fiddler replay, but in this case we want to create a realistic quick JMeter script that will run that entire scenario, and we can run it load. So as you can see, there's the request response pairs, there's the gets, the posts, everything that's happening from an API perspective, all captured through into JMeter. Of course, there's a recording tool in JMeter that would allow you to do the same kind of thing as far as a proxy is concerned, but we needed the spider to go through and generate all of those 3,000 transactions. So now we've saved that, we're ready to go and actually execute that. So we can use something like Taurus, and I'll be showing you that in a later demo. But that gives you an idea of how you can get every single type of transaction in under 20 minutes. So this was a 25-minute demo, and we're going to show you within that 1 hour slot, I'm going to be able to do a digital twin of the entire website combined with running it in continuous delivery. So be able to run it in your Jenkins build, getting those metrics quickly, understanding what the volume metrics look like on the left hand side. Very fast and very simple. It's literally a few clicks. Okay. So let's quickly touch. We've process mined. We've got all that information out. What do we do with it? Well, you saw the Excel spreadsheet. What I do is I take that Excel spreadsheet and I create a business process modeling notation XPDL output. So what you can see on the right hand side is the business process tests and the individual transactions all mapped across from my digital twin. Now this could come through from your APMs, your DXIs, and also things like Probit that allow you to take anything from these two and output them into a business process model. You could also use business process testing. We're going to look at how you use test data, create test data as well. And these are all ways of visualizing and understanding what that digital twin looks like. So let's look at some quick basics. The first thing, of course, you're looking at a business flow, which may move into different systems depending on the amount of complexity. You might have non-functional requirements that say between login and a search tab, you're expecting it all to happen within 5 minutes, or you may have some other NFRs that you're mapping to. So you need to be able to ask the question what your answer is, and all the way down to the transactions that we're going to do those request responses to prove the hypothesis. So it's really important. A test session, whether or not you're doing load, stress, benchmark, whatever it may be, or you're doing some kind of optimizations, it's all about profiles. So you need to have user profiles, which we've just captured. You need your interfaces, which could be all your APIs, which you can put something like Kali or with PortSwagger or Fiddler to capture those as well as some kind of noise. So this is the stuff that's underlining. This could be right into files. It could be ambient noise that's happening, updates happening. And then you're going to create scenarios that touch lots of different tests and lots of transactions. So how do you do this? Well, there's a lot of information with a standard flow, and what we're going to be talking about is multi-dimensional transactional data. So this is data that's in, let's just call it 3D. You've got lots of information, browsers, languages, network virtualization. We've got to take all that information and we've got to create a model with it. So my first recommendation is using a model-based testing tool. Quick example here, using testmodeler.io. I can create the underlying APIs for a valid or invalid username, some OAuth, whatever that may be, and generate lots of scripts out of the back. So all possible combinations of correct and invalid and valid scenarios. The next thing I'm going to need is a whole stack of data. Now this can be done using Test Data Automator or any other product. You can see here it running in Excel. I need to be able to generate lots of accounts, whether that be synthetically, so based on some kind of rules, or I need to go off and use a subset and crawler and pull the information from the different databases to give me a data set of valid accounts. I might want a huge stack of usernames with addresses all in a particular format, and I might need 1 million of those because that's the amount I'm going to be burning per hour. So using this tool, you can create things very quickly. You just literally select, say for instance, the product or the company or the address, and then you drag and drop to create synthetic data. Now, of course, that synthetic data needs to be valid, so you need to make sure that you're creating valid data. And the devil is always in the data, so you need to make sure that you've got data which is either valid with the system or, you know, is data that will be able to be inputted. So here's a quick example: loads of accounts, loads of usernames. What I want to do is just drag down like you would normally do, and I want to create millions of those. So this is really where you've got to think about your test data, and you've got to think about the way that you're going to approach it. What happens is your test data is pictures. So the example I'm going to give you, we're working with Amazon and eBay. We had to create millions of images which would feed through the system, which could be pictures of trainers or t-shirts, and we needed to use computer vision to actually identify them. And of course there's a misclarification rate, so it was about 20%. And if we overtrained the algorithm, there was a downside on the amount of compute power that was required. So quickly looking at this example, 3 different algorithms, one takes 1 second, the other one took 4 seconds, and you can see one was 67%, the other one was 73%, and the overtrained one was 75%, which of course is the best one, but it takes 1 minute and 25 seconds. And if we're trying to put through 11,000 images per hour, we're not going to be able to use Model 3, but Model 2 may or may not be able to create enough through that 1 hour period. So we have performance that could potentially require things like images, but also we've got algorithms that may take increased amount of times, and it might be 20% increase or 100%, or as you can see with Model 3, it's just not feasible to be able to run that. So we need to think about what's the end outcome which you're trying to achieve, not just how quickly the API is able to flag that image and upload it. It's about it being able to process it and it to be available on an Amazon endpoint. So here's a quick architecture of what we're using and how we're using performance testing against it, or performance engineering. So you've got to think about things like MongoDB. You've got to think about things like GraphDBs, so things like Neo4j. And you've got GraphQLs, which are coming through, making queries from the front end to the back end. You've got publishers that potentially are going through something like Kafka and other streaming services to get that data written into the database. So there's a whole stack of points which you need to check across here. So check out gated.ai and the methodology behind that, and you'll find out more. With this type of architecture, you're going to start seeing things like Kubernetes, and you're going to start seeing things like micro-containerization and therefore unified compute platforms. So this could be in AWS, this could be run locally, this could be run on your machine, but you've got to be able to configure these environments so that they perform the best they possibly can. So let's have a quick look at running this stuff locally. Of course, I'm running on an Alienware M51, so the Area 51 device, so I've got a lot of power. I've got 32 gig of RAM, but even with 32 gig of RAM, my memory's pretty much maxed out when I'm running my Kafka instance, my Mongo, my Neo4j, my Postgres. So I've got all of those Docker containers running and talking to each other. I'm now testing against that local host, whether it's using something like Postman or another layer. So let's have a quick look at the Kafka layer. So I'm posting on messages using JMeter to actually post into my Kafka. So there's producers and consumers. So that's the next level down. And then finally, I may be going into something like MongoDB. So I've got performance counters that I need to look at there. And obviously I'm looking at data at those different layers. So of course, we don't want to run load locally. We need to be able to deploy it into our environment, our performance environment, and then actually be able to run that geo-realistically, so either using VPNs or having geo-realistic load coming from different load injectors in different locations. In the previous example, we're hosting everything locally. Once we deploy those containers into your SaaS platform or multi-cloud configuration, we then need to create geo-realistic network virtualization. Okay, it works locally, but now we're going to have to deploy it into the cloud. So you might have multi-cloud configurations over AWS, Azure, Google, doesn't matter where the endpoints are, you need to be able to performance test that. You also need to do it geo-realistically. So you need to create NV, network virtualization endpoints, using something like OpenSignal to understand. This could be Prometheus, which is deployed in your Docker container and giving you some performance counters. That also then could be writing out to Grafana to give you an idea of how that's performing. You can also use something like InfluxDB to then take the information that you say, for instance, this is coming from JMeter as a source, to tell you what the load is, what you're putting on. So you can bring all this information together using time series databases such as InfluxDB. Okay, let's run this. So in the previous demo, we created our JMeter script. We'd also captured using Fiddler, and we used the perf driver to create this script. Now we're going to go and run it. Okay, let's execute it. So I've got my JMeter script on the left-hand side. I've also got my YAML wrapper on the right-hand side with my tokens. I'm now going to run this YAML file. And as you can see, I'm running this Taurus injector locally. The next step will be to run it in Jenkins, but also I want the report to actually come out and go into the cloud. So what we can see here now is I've got a URL link, which is to here. You can see my Taurus container, which can run in a Docker container or any other environment. You can see that it's waiting for the servers. Once this clicks through, what we're going to start seeing is real live data. So within this, we can see that my users are going through, my reports coming through, and I've got my information of my requests, how many VDUs I'm running, virtual users, and response time on the system. So the next step, you can see all of the actions and the pages, so we can have tolerances on there if we were trying to say that this must come back within a certain period of time. So we can see here, we've got all the information, the amount of users, the response time, all the way through. And we can see by quickly looking at this, that actually the bulk cart area is taking about 12 seconds to process. So obviously that is a bit of an issue, and it's something we need to look at on the website. So this Taurus is now run. And the next thing we're going to do is we're going to run this as part of Jenkins. So I've got the Taurus using a JMeter wrapper. I'm going to do a build. So I'm going to kick the build off. And if we quickly go and look into that build, what we're going to see is we're going to see it executing Taurus. And the great thing about this now is exactly the same thing. We can look for that URL, which it's going to generate in a second, and we'll be able to watch what's happening. So here's the URL. I can go into the Taurus test, and I can see this executing right now, and the request responses, it's ramping up. You can see some information here as far as logging. We can also go into this dynamic one and see that we've got an issue potentially here where we're getting quite a large response time, and again we might want to investigate that. So again, we're getting the same information, but this time it's now coming directly from our Jenkins build. That's now executed. I can now run a second test. So we've got our baseline data, and therefore we're getting these aggregated trends. So here's the baseline data that we've seen based on that digital model that digital twin we've created. The next thing we're going to do is we're going to rerun it and see if there's any deterioration in performance. So I'm re-executing now. I can see here there's a few spikes, which it looks like it may have some issues. I get an overall view again of the load, and as you can see, this is running at 2028. So I've done this live while I was chatting to the MIT guys. If I go through now and quickly look at our performance trend, last report over the two builds, what I'm going to get is any differences that I see in the 95 percentile or any of the other values. So this gives us a quick start for 10, and if these have increased by a certain percentage, we could fail the overall test. So this enables continuous performance. So a GitOps approach allows us to check in any new code, rerun, and rebaseline. So it gives us all the information, but it also gives us the output that we need. The second thing was around getting data from something like InfluxDB and allowing us to put that data into something like Grafana. So you can see here, this is the tick stack that I've downloaded. I'm including the listener into my scripts, and this allows me to pass the information from my JMeter into my tick stack. Once in Grafana, we can start looking at what the real performance is. So not the request response pair, which came back in 22 milliseconds, is it posting it on Kafka. You can see I'm posting 25,000 items onto Kafka, and it takes about 18 minutes. So actually, when I'm looking at my data, it's only at the 18 minutes past that I can see that Kafka's finished. And then I can look at the next component, which might be the GraphDB, and that will then continue to a certain time. And then, of course, once my item's been listed onto Amazon or eBay, I'm not going to see that data until 30 minutes. So they're the performance numbers that you need. So what are we trying to do? Well, we're trying to identify potential bottlenecks. So this is using root cause analysis and pinpoint failure analysis to identify any memory leaks, JVM configuration issues, database issues, indexing, etc. So you might be saying, well, this is what an APM will do. Now, you're absolutely right. It will look at this request response area, but it won't look at the processing, because typically real user monitoring doesn't include DOM interactive, DOM rendered, etc., etc. It's not using a browser proxy, so it's not very realistic. Now, of course, with real user monitoring, you can get more information, but really when it comes down to getting the underlying interactions, so for instance, the GraphQL embedded into that query that's coming from your front end, you need to be able to track that through. So this is where we need to be able to do this root cause analysis all the way through. We also better want to monitor it over time to see what happens once we've actually fixed the problem, and keep an eye on it that it doesn't happen again. Once I've identified the bottleneck, I can use something like Alchemist, which is AI driven, to actually allow us to optimize that. So for instance, the baseline configuration for MongoDB, I then look at what the optimized one is based on the increased throughput that I'm trying to achieve, which could be payments per second, not IOPS. And then once I've optimized that endpoint, I can rerun this, and it's now configured. The other thing I need to be able to do is something like create a digital twin. So in the example of the Brexit, post and pre-Brexit, we had to take a digital twin of the pre-Brexit configuration and then model what a post-Brexit would look like, because that scenario doesn't exist in production yet. But you need to be able to keep on refreshing from your production environment because loads will change. So when it comes to volumetrics, data visualization tools such as Splunk will give you the ability to visualize all that information. So you need to be able to visualize where the load's coming from. So that could be different regions, but also the data associated with it, because within time series data there's a huge amount of information which you need to be able to analyze and at least have some cascading KPIs that make sense. So as I mentioned the MIT project before, if you guys want to get involved and you want to do some performance, there's a link to the MIT Safe Paths. There's also the link to the charity. We're all volunteers. I've added in the Slack channel and also a link if you want to register as a volunteer. I hope you've enjoyed this session. If you want to learn more, check out the podcast that I did with Joe, number 3 on the podcast list, which can be found at testguild.com/P03. You can also get in touch with me on LinkedIn at linkedin.com/in/automation. I'm more than happy to help you by providing you further detail around this presentation.